If you understand this curve, physiology becomes easy. Let's learn about the hemoglobin dissociation curve. In earlier video, we discussed the structure of hemoglobin in depth. If you haven't watched that video, please watch that video first. Now let's learn about this. Now imagine hemoglobin as a 4-seater car. So 4 seats, each can carry 1 oxygen molecule. So 1 hemoglobin molecule can carry 4 oxygen molecule at once. What is the function of hemoglobin? Carry oxygen from lungs to tissue and bring CO2 back from tissue to lungs. Now let's learn about the hemoglobin dissociation curve. On the x-axis there is a partial pressure of oxygen and on y-axis percentage saturation of hemoglobin with oxygen. The shape of curve is sigmoid because of the cooperative binding. So each O2 binding changes the hemoglobin shape and increases the affinity for next O2. This progressive binding creates the sigmoid curve. Now look at the top part of the curve. Partial oxygen pressure is 100, hemoglobin saturation is 97 to 100. Even if pressure drops slightly, hemoglobin remain well saturated. Think of your mobile battery at 100%. Even if it drops to 90, your phone will still work perfectly. So hemoglobin doesn't panic if oxygen pressure drops slightly. But vice versa in the other case. Small drop in partial oxygen pressure releases large O2. Now this curve shift to the right and left. Remember one thing, whenever you give something to somebody, it is the right thing, the gesture is right. So when curve shift to the right, that means hemoglobin is giving oxygen to the tissue. Now tissue require this oxygen during increased temperature, increased CO2, exercise, decreased pH. Now opposite thing happen when curve shift to the left side because here hemoglobin loves oxygen. There is an increased affinity towards the O2. So they release less oxygen to the tissue. Causes is decreased temperature, decreased CO2, increased pH. So your exam tip is hemoglobin oxygen dissociation curve is sigmoid due to cooperative binding. Left shift increases oxygen affinity and right shift promotes oxygen release.